students. In this video, I am going to discuss solid state, lattice, and next one unit cell, space lattice, and the primitive unit cell, and what is the center of unit cell, what is primitive, and next one explanation of 7 crystal systems, and after that packing efficiencies. Packing efficiencies questions plays important role, and 7 crystal systems bond angles and edge length they're asking. Edge length ABC and bond angles alpha, beta, gamma, how we arranged, and examples, and its Brevis lattice also they're asking in the examination. So we'll concentrate how easily we can remember also. End of the class I'll give you. Okay. So now first let's begin with the lattice. Some important definitions I am writing, students. Lattice. Lattice is nothing but array of particles. That means arrangement of systematically arrangement. Array of particles. Array of particles. Next one, space lattice, or also call it as crystal lattice. Both are same. Space lattice and crystal lattice. Here, what is this? Space lattice is nothing but array of particles in 3D space, in three-dimensional space, systematically arranging particles, that we call it as space lattice or crystal lattice. Okay, students. Now, next one, crystal lattice, unit cell. We'll discuss about the unit cell. Okay, now next to definition, unit cell. This is one of the important point. So, smallest portion in crystal lattice. Smallest portion in crystal lattice. Okay. Now I am going to draw now unit cell. This unit cell continuously it can repeat now. Then finally we will get the crystal lattice in three-dimensional crystal lattice. Now I am going to draw the structure, students. The cube unit cell, simple smallest portion, and separately writing here. This is one square. Take another square like this. Simple. That's all, students. This is unit cell. Okay. Clear? Okay. 1 second. Another color. Okay. Now you can expand this one in three-dimensional space. No, x-axis, y-axis, z-axis. We are taking x-axis, y-axis, z-axis. Okay. Now here particles at corners. Corners we have, students, and centers also we have, that I can show. For this cube, 4 particles. For this cube, 4 particles like this. Now here we are using edge length. Edge length, this is A, but this edge B, this edge C. Same like angles also. Here angle alpha, here angle beta, here angle gamma. So 3 edge lengths and 3 interfacial angles. Based on that, we are giving the crystal system. 7 crystal systems we are giving. How many crystal systems, students? 7 crystal systems. That I am writing here. Unit cell having 3 edge lengths and 3 angles. Exact word is interfacial angles. Interfacial angles. Those we call it as alpha, beta, gamma. Alpha, beta, gamma. Urge length students, urge length means I am writing here A comma, B comma, C. Okay, alpha, beta, gamma. So finally these three here, three. Totally 3 plus 3, 6 parameters. How many parameters students? 6 parameters, right? This 6 parameters, based on 6 parameters, crystals are classified into 7 systems. I am writing here point. Based on 6 parameters, crystals are classified into 7 systems. 7 systems. These are all basic points, students. If you don't have command and basic points in solid state starting, next topics also you get confusion. We are speaking 7 crystal systems and we are using Brevis lattice. What is this words and all? First I'll give you clarity. Okay, now next one. This is one part we completed. Now I am talking about unit cell again. Unit cell, we have 2 types, students. One is primitive unit cell. Primitive unit cell. Primitive unit cell is nothing but simple unit cell. Lattice points only at corners. Only at corners. Okay. Next, this one is centered unit cell. Centered unit cell means one center is there. So means here it is primitive. Primitive is nothing but definitely particles at corners, particles points, the lattice points I can show. Primitive means its corners, particles at corners plus one center. It has one additional point, one center. Here center again 3 types, students. What is that? One is face center, another one is body center, and the last one is edge center or end center. Okay, so number of particles calculation in face, body, edge centers also I am going to upload the video, but today's video I am going to discuss the 7 crystal systems, bond angles, and next one interfacial angles, its Brevis lattice, and examples, including examples and simple unit cell packing efficiency also. Now, finally, tell me students, how many types of unit cells? 4. Here this is 1 primitive and this is 3 finally. Totally how many? In all, if, write the point, if all 7 crystal systems exist in 4 lattice types. In 4 lattice types. We should have 28 lattice arrangements. 28 lattice arrangements. Based on 6 parameters, how many crystal systems I said? 7, right? And we should have, what is this? Totally how many unit cells here? 4 unit cells, right? 4 into 7, 28. We should have 28 lattice arrangements. But, important point, but in nature, we have only 14 lattice types. 14 lattice types. So which are known as Brevis lattice. Brevis scientists have given this point. That's the reason we call it as Brevis lattice. Actually, we expected 28, but in nature availability is only 14. But who has given this point? Scientist Brevis. That's the reason finally this 14 lattice types we call it as Brevis lattice. Is it clear introduction part now? what is unit cell, what is lattice, what is space lattice, what is primitive, what is center. Okay, finally, how many crystal systems existing? Clear. Now I am going to the seven crystal systems table. This table plays important role, students. Direct questions they are asking. Alpha, beta, gamma, angles, how much A, B, C, either equal or not equal. Direct questions only they are asking. There is no twisting here. But thing is, uh, student is not able to give answer. Why? Because so we have to remember, we have to by heart this one. But the by hearting way only how easy I am going to give. So write down first seven crystal systems. Seven crystal systems. So first one, first crystal system. I am writing crystal system. Okay. Now next one, urge length. Urge length. Okay. Next one, interfacial angle. Interfacial angle. Next, brevis lattice. Brevis lattice. And the last column, example. All competitive points I'm covering here. Board level, you may expect some questions, but competitive, it plays very important role. Okay, students. Now let me draw the structure. Okay. First one, first crystal system, cubic. It's very simple. Easily we can remember. Cubic. Okay. Second crystal system, I'm writing here. Second crystal system, tetragonal. I have selected here tetragonal. To give the shortcut, I have arranged like this, tetragonal. And the third one is orthorhombic. Orthorhombic, monoclinic, orthorhombic sulfur we have studied no in the 16th group elements time. And fourth one, monoclinic, monoclinic. And fifth one, triclinic, triclinic. And sixth one, you can adjust with this line, students. Okay. Now tell me sixth one, anyone? Sixth one is rhombohedron. What is that? Rhombohedron. Rhombohedron. Okay. Rhombohedron. This is also called it as trigonal. Rhombohedral. Rhombohedron. Both are same. And next one here, this is another name is trigonal. Trigonal or trigonal, your wish. And the last crystal system is hexagonal. What is this, students? Hexagonal. That's it. Now we'll see all the questions. Okay, go back to this one, seven crystal systems. Okay, finally, I am telling you, chemist traveling old Madras to Richmond House. What is the shortcut I am giving to you? What is the shortcut I am giving to you here? So, chemist traveling, note point, chemist traveling, old Madras road to Richmond House. This is my shortcut. It is useful, I think, in examination. What is C? C is here, cubic. And T is nothing but what is this? Tetragonal. O is nothing but orthorhombic. M is nothing but monoclinic. Again T. So T is nothing but this is triclinic. Next R is nothing but rhombohedral. Last one H is nothing but hexagonal. Is it easy, students? You can try like this. Definitely you feel comfortable during examination. Okay. Now come back to the cubic. Edge length. Here very easy, students here. What is edge length? A equal to B equal to C and alpha equal to beta equal to gamma equal to 90 degrees. See, this is no confusion. Here also no confusion. And Brevis lattice. What type of Brevis lattice it can show? It can show primitive. P means primitive. Primitive is nothing but the particles only at corners. Okay. Along with this, it can show face center and body center also. Face center, body center. Okay, students. Now, next one. Examples. Examples I am giving here. Generally, sodium chloride, zinc blend, ZNS. Okay, and copper. These examples. Examples also plays important role. These examples we have to little by heart. Zn, zinc sulfide is only primitive unit cell, ma. Primitive unit cell. But what is this? What is this? Another one, ZnO, zinc oxide is there. That is primitive plus one more is there, graphite. I can show down examples. This is tetragonal. Next one, tetragonal. So before going to the tetragonal, let me give another point, students. See, the easy way we are working this table. So next, more disordered system. We are seeing in examination, students. So where A equal to B equal to C, alpha, beta, gamma is 90 degrees. What type of crystal? It is cubic. Next, more disordered. More disordered means triclinic. Please make a note this one. Triclinic is more disordered system. More disordered. Means, I think you got it my point. Here, A not equal to B not equal to C and alpha also not equal to beta not equal to gamma not equal to 90 degrees. That's it. More disordered system, this one. Next one, this it can exist only primitive. And examples. Triclinic examples, no? This is important, students. Potassium dichromate. Orange crystals we have studied, no? And copper sulfate pentahydrate. That one. Next one, boric acid, H3BO3. These three examples. But many times they asked K2Cr2O7, copper sulfate pentahydrate. Okay? So more disordered system. Next easy part. Is which is frequently asking in examination, hexagonal. Hexagonal also easily we can remember. Here alpha, beta equal to 90 degrees, but gamma equal to 120 degrees. If you have seen gamma equal to 120 degrees, there is no doubt that is hexagonal. And here edge length A equal B not equal to C. Only one not equal to C. And next it is exist as a primitive, students. And next one, examples. Again examples plays important role. Graphite and zinc oxide, cadmium sulfide. This examples. Next one. Okay. Next, these 3 points easily we can understand and remember also. Next, another point. So here tetragonal I have written, orthorhombic here I have written. This edge lengths are same, students. Edge lengths no doubt. Sorry. Angles no doubt same as it is you can write. Alpha equal to beta equal to gamma equal to 90 degrees. Even orthorhombic also, alpha equal to beta equal to gamma equal to 90 degrees. No doubt. First 3 you can remember like this. But here how to remember? This is one B not equal to C. And here A not equal to B not equal to C. So C. So triclinic more disordered system I said, no. Here orthorhombic also A not equal to B not equal to C. But here these are 90 degrees. But this is not 90 degrees. Easily you can remember orthorhombic. And orthorhombic will get more questions, students. Why? Because it can exist all type of crystal systems, primitive and face center, body center, and next one, what is this? Edge center. Primitive, face center, body center, and next one edge center. All type of crystal systems it can exist. That's why it plays important role. And here examples we have studied in the 16th group elements: rhombic sulfur, orthorhombic, rhombic sulfur. Okay, rhombic sulfur, and the next one sulfates only. Barium sulfate, sulfur we are taking. Next one potassium nitrate. Potassium nitrate. Okay. Next one, monoclinic. Monoclinic, what is the point? What is the point? Here, the same way you can write, the same thing. Same orthorhombic is same thing, no? Here also same thing. A not equal to B not equal to C. And the next to alpha equal to gamma equal to 90 degrees. And beta not equal to 90 degrees. Please make a note this one. Alpha, gamma 90 degrees, but beta not equal to 90 degrees means monoclinic. Okay. Now next one, what is this? Monoclinic exists as primitive and edge center. Primitive and edge center. So examples, monoclinic sulfur, monoclinic sulfur, monoclinic sulfur. Next one, Na2SO4, 10H2O. Na2SO4, 10H2O. That examples we are taking here. Now, next almost we completed. Next one, this one, rhombohedral. Rhombohedral, what we have to remember here, again it can repeat. Once, what is this? A equal to B equal to C. Here 1 not equal to C. Here all not equal. Here all not equal. Here all not equal. Easily you can remember. And the next one is, it is repeating. Again first one repeating. A equal to B equal to C. And here alpha equal to beta equal to gamma not equal to 90 degrees. These two same thing. These two same thing. Okay. Here these two same thing. And this is like a first crystal system. A equal to B equal to C. Easily you can remember. It exists only primitive, students. And rhombohedral examples I am writing here. I am writing examples. Calcite. Next one. The calcite is nothing but calcium carbonate. And cinnabar. Calcium carbonate and cinnabar, HGS. This is mercury, cinnabar. That's it, students. Once again, I am telling what is this. First, what we have to write. Chemist traveling. What is the shortcut we used, students? Is it completed all crystal systems? Yes. See, note. Chemist traveling Old Madras to Richmond House. Easily you can remember. Cubic. What is this next one? Tetragonal. Next one, orthorhombic, yes. Monoclinic, what is this? Triclinic, rhombohedral. Next, hexagonal, right? After writing, see, all are equal. Then what is this? Cubic, right? Next, more disordered, all not equal. This is not equal, this is also not equal. How you can easily remember? Triclinic. Next, hexagonal is nothing but angles. Once you see the angles, you will come to know. Alpha, beta 90, but gamma 120 degrees. If you see, then definitely that is hexagonal. A equal to B not equal to C. Here we have to remember this one. Okay. Now next one. Next, afterwards, see, tetragonal. This is, these angles you can remember. These three angles, no change. But here, what is the change? Not equal to B not equal to C. And here all not equal to C. You can remember. Tetragonal also you will take examples. Generally tin oxides, very important one. Tetragonal also important one. What is this? It exists as a primitive and body center. Examples, no? Why I have not written here? This is one of the repeatedly asking questions. That's why I am telling. Tin oxide, white tin, and tin oxides, SnO2, and titanium oxides, TiO2. These are all examples. And copper sulfate, this calcium sulfate, not copper, calcium sulfate. Copper is and this one here, triclinic, but this is calcium sulfate. Calcium sulfate is, what is this? Tetragonal. Okay, students, ABC angles, and next one, ABC urge length, alpha, beta, gamma angles. Both are plays important role. towards competitive examination. Starting remembering during examination time it's difficult. Once you start work on this, definitely it is helpful for you. Okay. So more disordered system, triclinic. Gamma 120 degrees, hexagonal. And here three angles are same, but here you can remember like this. Same thing here repeating. And here these three same. First one all equal, second one only one not equal, and this three same. Again this three same. Okay, next one again first one repeating, and next one second one repeating. Like this I have written. Okay, easy way I have made the shortcut, students. So please work out on this and get ready for the examination. Do well in exams. Okay, students. Thank you. Thanks for watching. Please like, subscribe, share our channel. Okay. Thank you.